Okay, everyone, we're taking a look at questions 7 and 8 from the Chapter 7 practice test for AP Stats. So let's take a good look at what we have here. Question 7 is a multiple choice thing. Which one of these is true? Some interestingly named Dr. Stats is going to plan on tossing a fair coin 10,000 times in hopes that it'll lead him to a deeper understanding of the laws of probability. Which of the following is true? So is it unlikely that he will get more than 50,000 heads? Well, I don't know if I would say that is unlikely. I mean, certainly we should be approaching 5,000 heads flips because that is half of 10,000, and that is what we would expect to get. 0.5 times 10,000 is 5,000. So I would say that's unlikely that he would get more. Remember that there is some sampling variability. So more than 5,000 heads may actually happen. In fact, it's probably going to happen. Whenever Dr. Stats gets a string of 15 in a row, it becomes more and more likely that the next tossed will be a heads tossed. Well, that's not true either. Every toss has its own probability. Each toss is 50-50, and just because you get 15 tails in a row does not mean that the universe owes you a heads toss. They like to say that the coin has no memory of what happened before. So every time you toss that coin, it's 50-50, no matter what happened beforehand. The fraction of tosses that results in heads should be close to 1/2. And I like that one because it says close to 1/2. So that sounds true. Not exactly 1/2, but close to 1/2. And the chance that the 100th toss will be a heads will depend on the first 99 tosses, and that violates that thing that we were just talking about. The coin has no memory of those first 99 tosses, so not going to happen. So E is not all of the above are true. Of course all of the above aren't true. Only one of those is true. So our correct answer here is C, which leads us to number 8. A study of a college freshman's study habits found that at the time and hours that college freshman used to study each week is approximately normally distributed, with a mean of 7.2 hours and a standard deviation of 5.3 hours. Oh, that's kind of nice. Let's give me some space here for letter A, B. Might as well do C and D also. Oh, what did I just do? Okay, so this has a lot of the guts of what we've been doing in AP Stats, or what we will be doing in AP Stats. So we have, what is the probability that a randomly chosen freshman studies more than twice the average number of hours? So we have a randomly chosen freshman. This isn't a sample of freshmen. This is just one freshman. So his probability, well, we're going to need a sketch. And his sketch is going to be that of a normal curve, because we're told that our population is normally distributed right here, approximately distributed. So we're also told that the mean here is 7.2. Up over here, that has a z-score of 0. We're told that we have a standard deviation of 5.3. We'll do this over here of 7.2 plus 5.3. I think that's 12.5. That has a z-score of 1. And then a z-score of 2 would be maybe about there. And then 5.3 plus 12.5, that's 17.8. That has a z-score of 2. So more than twice the average number of hours. So basically we're saying, what's the probability that the number of hours is more than twice of 7.2. 7.2 times 2 is 14.4. So just taking a look at the roadmap that we have here, 14.4 would be somewhere around there. And then we're interested in this area, just greater than 14.4. So this is meant to be a multiple choice question. So the first thing we're going to need is a z-score. So our z-score is going to be 14.4 minus average of 7.2 divided by a standard deviation of 5.3. And boy, I wish I had my calculator. Let me grab it. 14.4 minus 7.2. 14, no. Let's get our fraction, friend. 14.4 minus 7.2. And then the whole thing divided by 5.3. Cool, that gives me a z-score of 1.358. Remember, I like your z-scores to be 3 decimals. 1.358. And so this probability is equal to, this is going to be a normal CDF. I think everyone is enjoying doing this now. Where the lower is 14.4, the upper is really infinite. The mean is, what does it mean? 7.2, and the standard deviation is 5.3. So let's go ahead and do that on our calculator. Normal CDF. Second distribution, normal CDF is number 2. Our lower is, now I wish I could remember that number, 14.4. I clicked the wrong one. 14.4. Our upper is 1E99. Our mean was 7.2, not 72, 7.2. And our standard deviation was 5.3. That looks correct. And that gives me us 0.0872. 0.0872. That's 8A. 8B. Describe the shape of the sampling distribution with 55. Okay, so we know that is a very large sample. And the sampling distribution for X bar, that would mean that our central limit theorem is going to take hold, which means that our sampling distribution, well, even without the central limit theorem, since our population is normally distributed, our sampling distribution would be normally distributed. And we're just worried about the shape, so the shape is approximately normal. It's going to be really close to normal, actually. Approximately normal, since that doesn't look like the word normal. Let's put the word normal in there. Since the population is approximately normal. Equivalently, you could have said the sample size was greater than 30 and cite the central limit theorem, but we don't need to do that. But you would also be correct if you did that. What are the mean and standard deviation for the average number spent, average number of hours X bar spent studying in a sample of SRS of 55? That's a sample. So our mean of our sampling distribution, that's going to be the mean of the population. We just said that was 7.2. The standard deviation of the sampling distribution, that's going to be the standard deviation of the population divided by the square root of the sample size. So for us, that's 5.3 divided by root 55. And let's get our calculator again, 5.3 on root 55. Cool, that's 714. Just taking a look here, our mean is given to one decimal place, so we could probably get away with going to only 2 decimal places here. No one's going to really throw an argument if you put in 714, but 71 is certainly enough for that question. Okay. D, what is the probability that the average number of hours spent studying is greater than 14.4? And I forgot the most important part here. Studying in an SRS of 55 students. Well, we already know the center shape and standard deviation here. So really, we're just figuring out what is the proportion of that the average study time is greater than 14.2. Okay, and we'll need a z-score. And that's going to be equal to that 14.2 minus the standard deviation of our sampling distribution divided by the standard deviation of our sampling distribution. So 14.2 minus 7.2, that's just 7. So we're doing 7 divided by 0.71. 7 divided by 0.71. That's 9.859. 9.859. Okay, so that's an interesting one. That's a really big z-score. If you remember, we got 7.2 here, and 14.2 is way out over here with a z-score of 9.859. That's going to be very little area at all. Probably really close to 0. Let's see what the calculator says. This is normal CDF, where the lower is 14.2, the upper is infinity. The mean is 7.2, and the standard deviation, that is 0.714, calculated at second distribution, number 2 for normal CDF. Our lower is 14.2. The mean is still 7.2, but now our standard deviation is 0.714. Look at how much we reduced that variability from 5.3 to 0.714. So it should make sense that we're going to get a really small number. All right, here's our really small number. Notice at the very end here it says E equals 5.516 E to the negative 23 power. That's going to be 22 zeros followed by 5. It's a very small number, and I usually tell people that if it's bigger than e to the negative 5 power, you can just put a 0 here. So 5.5 times 10 to the negative 23, which is basically 0. That's 0 enough for anybody. Letter E, would your answers for A through D be affected if the distribution was distinctly non-normal? No, it would not. Nope. The sample size is greater than or equal to 30. So with the central limit theorem, any sample from the population of this size would have a normal sampling distribution. Ooh, you know, I think what we really should be saying is any sample of this size, not population of this size. Any sample of this size would have a normal distribution. Yeah, that's a better way to phrase it. Okay, so I think that's it for question 8. We're going to do question 9 next, so we'll stay tuned for that.